Right, this is about my 1940s, late 1940s Cromwell Mk3 S800. It's new to me. I've only just got it up to this stage today, so I'm just going to have a quick run through, or maybe try to make it as quick as I can anyway. Around the late 1940s, the Myford ML7 was selling for about £47. This was selling for £450, but this isn't a hobbyist machine, hobbyist lathe, or a model engineer's lathe. This was like for big companies. Bolton Paul Aircraft in Norwich bought this. They started off a brief history about this company in particular. Started off around the late 1800s, 18th century, sorry, 1790, somewhere around there. There's a young farmer's boy that moved to Norwich, opened up a blacksmith shop, and then his business became bigger and bigger. He started moving into more and more things. Skip forward to the 20th century. The struggle because of Chinese imports around the 1960s and the 1970s, it was really killing off trade because people could get more machines dirt cheap from the Chinese that weren't that great quality, but it still put them under strain. So they sold the company off in the late 1970s, and then that company that bought them asset stripped them and split the company up, sold it off in parts, asset stripped them, and made them defunct within 3 years. So nearly 200 years worth of company got dismantled inside 3 years, just for profit. Massive unemployment. It's a real shame. But that's Bolton Paul. They, by the way, this lathe was made after after World War II, so I know that this hasn't actually been used to make any World War II aircraft or machine parts. But in World War One, Bolton Paul were the biggest manufacturer of the Sopwith Camel, which is a very famous British World War One aircraft. They made around about 550 of them for World War One, well before this lathe, obviously. The company that supplied it was Alfred Herbert in Coventry, and they were a massive company in their own right, and they were multinational. And the manufacturers were J. Evans and Son in Portsmouth, and they were a massive company as well. So it just shows the British were huge before the Chinese jumped in. I'll start from the bottom, which was tailstock, then the headstock, and then the post. It's powered, I've got lights on it, it's powered from a fuse spur that I've stuck in, and the cable goes up the top, needs clipping at the top, and then it goes down to the cupboard. The original shutter doors here, some of the slats are bent, and I think some are missing as well, so I've had to buy another one. I didn't think about the finish on that, by the way. This is damn hard to get off, so I'll figure out a way to get rid of all these fingerprints, greasy fingerprints, and try not to touch it again. That's a cabinet to hold all the bits. That's one light. That lights up inside the cabinet so you can see stuff, obviously, right at the back. I've got a junction box up there. One goes off towards to the switch, and then from the switch to the light. And you've got another one coming to this switch as well, and then from there, it's coiled inside, ready to go up that post to a light that's going to be on the top. And I've got another wire coming from the junction box down to here that's got a connector block on the end of it for something if I decide to put another light somewhere. So that's that. Originally that didn't have a washer. All that was just a nut against the paintwork, so I decided to make a washer for that. I made all this lot myself as well, not the switch, obviously I bought the switch, but the plate I had to make because originally it had a steel plate that was brown with rust and corroded, so I made all that. Right, tailstock, and there's no handle on this end for the lead screw. There's no half nuts either. These are just solid nuts. There's one that side, one that side, both about that long. This one, that one's just a solid. You just bolt that to the carriage apron, sorry. And then that one is an adjuster. So you tighten it with some slots in the actual nut itself to pinch them back, to basically move the carriage along. But it isn't moving, obviously, because of that nut. You tighten that up so there's no backlash. That's got a fine adjustment on it as well, so you can undo that nut and then move that up and down a little bit. And you've got another screw there to tighten it together, because that clamps that nut so it doesn't rotate. And so to stop you from having to, when you come to the end of your cut, to move straight back, to move back to where you are, instead of doing that and bending your wrist around and getting cramp in your wrist, the handle's at the front instead. So that moves the carriage left and right. And that one will as well. I'll come to that in a minute, the reason why it's got a drill bit through it. But you'll move that one. Well, both that handle and that handle is for the carriage movement. That's got a micrometer dial on it. Focus, damn you. It's not wanting to focus. That needs work on it because I haven't set this right. Basically the slot in this, the groove that in this that's supposed to socket into, is slightly out of alignment, so I need to figure that one out. What else? The top slide has got a full 360-degree rotation. It's got a circular T-slot in the cross slide, so the top slide can obviously rotate all the way around. It's got a scale there, which I don't like the look of. I'd love to replace that, and I think that's going to be the next machine I get, is a CNC engraver. I'd love to replace that. Also, I'd like to make new dials as well, because that doesn't screw on properly. I'd like to make that out of brass. I'd like to put more brass everywhere. This brass, I'd love to change that to brass, but I can't. I'll get to that in a minute. These are the way wipers. I need to get some felt or something for the back of these. You've got one for each corner. The carriage runs on its own rails, and then the top slide, tailstock runs on its own bed. So that's for the tailstock, and these two are for the carriage. So anyway, you've got one of these for each corner, and you've got one of these as well for the front of the carriage, another one for the back. So yeah, I need to get some felt or whatever it's called, way wipers, for that. Move along. I hate this. It's a real bad design. That is not one complete shaft that runs through. You got the shaft for the gearbox and everything that comes through, and it only sticks out by about half of that length. And then it's pinned, this bushing here, it's only about a 3mm pin, 3mm diameter pin, to pin it to this shaft, and then you've got another one there to pin it to this. So you've got a nice solid lead screw there, two damn long solid nuts, and all that force going through the carriage to cut it, and all you've got is two 3mm pins. So I'm going to take this out, take this bush out, make another bush with a wider bush with a key in it, and then mill the shaft that goes all the way through there and the end of this lead screw to accept that bush with a key in it. So at least then all that force is being driven by the lead screw. Then is being driven by a key. I'll probably make it about 4mm thick key instead of 2 thin pins. That I'm going to change to brass. I need a black washer for that. That's an oil sump. It runs in an oil bath. That end runs in an oil bath. You just got the one pulley in the middle. I'll take the top off at the end of the video. I'll make another short video. That I'm going to leave unpainted, because I know through experience with that lathe and another lathe that I had, you get red hot chips down here, you get oil down here, and all kinds of crap. That wasn't me, by the way. That's somebody else in the past taking a chuck off. It was more than like it dropped on that corner. So paint just ends up flaking off all the time. So I'm going to clean the primer off properly. I'll just leave that bare. Still needs quite a bit of cleaning. I've just put it all together to make sure I've got all the bits, because it's been made from one lathe that was on the top there and another lathe that I bought for space. That looks sacrilege, chucking all that nice lathe stuff down there, but I'm going to bunch it all together and put all the bits together and sell the other lathe on as parts or spares. All brass, even that is bronze. That's going to be changed for brass. That was nickel plated. It was heavily worn, thankfully, so it wasn't too hard to remove the nickel plating. Same as that at the back. That's harder to get rid of, so I'm going to have to figure out some kind of reverse electrolysis, if there is such a thing. You've got a back gear in there. Obviously that ties the ball gear and the spindle together. Either ties it together or unlocks it, and that one at the back is to engage the back gear or disengage it. I'd love to change that to brass, but I can't, because whoever's done it in the past, they've lost the ball bearing when they've gone to, they've more than likely took that out. There's a grub screw, a spring and a ball bearing that pushes into a slot in the shaft to stop the shaft coming out. But the only problem is they've lost the ball bearing and they've put one in that's a little bit too big. Forced it through the threads, so now it's in, it will not come out. So the only way to take that out now is to mill all this lot off, which I don't really want to do. So that's going to have to stay how it is. That's going to be brass. These, I'll come to that later. That's going to be brass. Everything fucking brass. Might as well. Right, inside here, that was nickel plated. Thankfully that was heavily worn, so I could rub that off easily enough. It was nice and flat as well, so I mean, it's easy to rub off. That was down here, but not anymore. I decided to put it up there because it's a lot easier. Instead of stooping down to look at the numbers down here, just look at them there instead. There's about 3 broken taps in this cast iron lid, because these are M2. So in the end I broke that many taps. I thought not anymore, so I ground them flat, put it there, drilled the holes slightly wider, 1.7mm the holes, and I just pushed it in with my thumb until it stayed in place. I just got a hammer and just knocked them in. So so the screws are now rivets, but that's being held very tight. I'll do that and it's going to pop off. No, my luck. Quadrants, you don't get one solid quadrant, it's all 2 bits, which in my eyes I actually prefer. That's better. And it doesn't seem like it's going to be a nightmare to change the gears either. You don't have to get to the back. You just undo the knots, take the gears off, put new ones on, tighten them all back up again. That's a great idea, space saver, because as you know, when stuff rotates, it either tightens a knot or loosens a knot that's holding something on, if you get what I mean. It's like if there wasn't a space, a very, very slight space between this nut, the washer, and the actual bush that runs inside, the key bush that runs between gears, that holds the gears together, when that rotates, it's either going to tighten this nut up onto it or loosen it if it runs the other way. This, instead of ringing two nuts together or having a wider bush and having a set screw through which damages threads, they've just got the one nut and it's slotted. If you use a slitting saw to cut it, so there's a third of the diameter, well, all of the side. It's about there. It's about runs about like that, the slot all the way through, and so you wind it on and you tighten the screw. The screw pinches the nut together and tightens it on the actual thread itself, which is a fantastic idea. I'll see if that gear is going to go on. It does, but it's just getting it aligned because you've got that other gear there and you've got a key there, so I'll do that later. I haven't got all the gears, unfortunately. I've only got some of them, which are pain in the backside because there's about 20 of them. You don't need 20 of them. The gears that it does TPI all the way from 7 TPI all the way down to 228. It does diametral pitch as well if you want to make worm gears, and it does BA 0 down to 11, so you can do BA with this. That's going to be a nightmare gear. 127, massive gears, about 8-inch diameter that is, for that size tooth. It's going to be about 8-inch diameter and a prime number gear as well, so it can't be divided with any dividing gear. And then you've got the metric scale as well, and you've got the fine feeds, which also has 2 prime number gears, the 59 and the 127. Fortunately for me, I've got a 57. That's not the 57. The 57 is in the cabinet. Bronze hinges. I need 2 black washers for that. It's got an oil sump nut there, which is brass. That just looks crap, so I'm going to make a brass adapter for the bottom to hold that on. I think I've already spoke about that. No, I haven't. I'm going to change that to brass, you know, mate. The whole idea of that, believe it or not, where is it? There's a bracket here which is bronze. No, that's for goes on that bar. There's a bar that sticks off the side and with a clipboard on it. So it's just a bronze bracket to hold a clipboard. That is, I think it's a voltmeter at the moment, but I'm going to have that so when the spindle's running, I get something. Somebody else is doing this for me. I'm not electronic minded, but something that converts rotational power to RPM, to volts or amps or whatever you need. So I'm going to have 2 scales on here, one for back gear and one for normal, so then the needle will move to tell me what speed the spindle's going at, and that is obviously going to be changed. There's 3 different threads, believe it or not. They can't just standardise and use one thread for everything. So that's one thread. There's another thread going into the bottom of that. There's another thread down there. Fantastic stuff. But that's going to be a light, and then that's the light shade, which is rather large. But I bought this about 3 years ago for another lathe, to make a light for another lathe, and I ended up getting rid of the lathe. I didn't like it. It's a Atlas Craftsman, I think it was. Now, next part of the video. Right, this is the other part of the video about the headstock. Now, this has been modified because I just did not like the original idea. even though it's served its purpose for about 70 years. Comes into my eyes, I don't like it, so I've modified. A previous owner packed it full of grease, which was very nice of him or her. The original design is like that. It's just a clear plastic cover that's been press fitted in, so you cannot get that out. There's no set screws or nothing. You can't get that off other than breaking it out. There was drip oilers. The reason why I don't like it, I'll explain it when I get to the headstock a bit better. Still needs cleaning off a lot, but there's a hole there, and inside, without that hole, think of that as just solid cast that goes across, because I've made that hole and tapped it, threaded it. That had got a wick oiler in it, and it was packed full of grease, and then it just got a small hole in the top there, and that wick goes down and just hangs, just dangles. Now you can imagine how little oil would get through that wick to drop into the actual gearbox. I'll come back to that in a minute to show what the plan is. That is an oil bath. You'd have oil up to the bottom of the gears at least, not all the way up to here, not all the way up to the actual gasket. There is a gasket there to stop oil getting through to the pulley, and that's supposed to be an oil bath as well, I'm assuming, although there's no gears or anything in there. All there is just that, and that's the bearing lock. Same as there, you've got a bearing lock there. Looks like pulled in that way. I don't know what this is for, because that just rattles. There's a piece of steel there. If I take that steel plate off, it's got a key on it that sits between two ridges. If I take that off, that's got a full 5 turns one way. Well, if I turn it 5 turns one way, then it'll turn 10 times the other way. So it's got 10 full turns on it. It doesn't do anything. It doesn't unwind or wind on. What that's for, I don't know. But this is the back gear, which is bronze, believe it or not, a bronze back gear. This is why they cost so much money. It's not going to go on at the moment because, like a noggin, they're tied together. So that now means that the back gear can work. So that's obviously the spindle will run a lot quicker. Sorry, the pulley will run a lot quicker than the actual spindle. And then that knobble on the top, that one there, you'll turn it to disengage the back gear. You'll turn that. If it goes on, I'll be amazed. Oh, it does. That's quite handy that they're both aligned. Now it amazes me why they didn't decide to design it so that it completely covers, because what people want to do, if they didn't know that was a flange fitting and they went to try to undo the chuck, they think, right, how do I lock the spindle? I know, put it in back gear. And that is more than likely why the back gear is slightly worn on the right hand end of the teeth, more so on that one. You can't really see, it's too shaded, because what's happened is it's only been part engaged. The back gear's only been part engaged when they've, you know what I mean, it's just that little bit when they've put pressure on, or die handles, threading, you know what I mean, lock the spindle with the back gear, they've been doing threading or tapping. Oh, nearly dropped the phone. So I've got to, now I know what it's like on the inside, I've got to figure out a way to lock the spindle without using the back gear, which is not a great thing to do. No, back gear's off, so leave that on. So yeah, with that being an oil bath, the whole idea is, what I want to do is make some brass cups and a standard off bias, say about 10-15 millimeters, something like that, and a brass lid, and the brass lid having some glass in the top, similar to that, so it's keeping keeping in how it used to be, with a plastic top, but you'll be able to see all the way through to the actual top of the ball gear itself. So you'll be able to see periodically, every now and again, just have a look, see if that's wet. If it's wet with oil, you know, you don't have to put any more oil in it. If it's starting to look a little bit dry, then you just undo the cap, put some oil in, put the cap back on. That will be the same, but like I say, there's no gears in that. All it is just the cap. So, excuse me, just burped. So that won't be used as frequently. What else is there to say? I don't know what else there is to say. I mentioned that, didn't I? About those. And I think I mentioned about that bush and the key. I'm going to modify that so it's not 2 pins. It'll be a keyed bush. And I need to make 2 key slots. A key slot in the main shaft inside there, and also a key slot on the end of this lead screw. But yeah, that's my Cromwell Mk3 S800. I think there's going to be quite a few videos in the future about this lathe, about modifications and changes, like different brass sections. Would you believe it? I'll stick a few pictures on at the end of this video to show what it used to look like, or parts of it used to look like, and stuff that you can't see. Stuff like, I doubt you'll be able to see. No, you can't see because it's completely covered. But the entire tumble reverse mechanism, which has got 4 gears in it, it's a normally 4. Now it's a tumble reverse there, and I've got 3 gears. The tumble reverse on that had 4. The main gear in the middle was steel, then the other 3 are bronze. The whole casing is bronze. There's a hell of a lot of bronze in that, but you can't see it. It makes you wonder why. It makes you wonder why they didn't just do it from a cheaper material. But it is what it is. But that was a very nice surprise when I took it all apart and I saw it. Oh, there's a big, solid unit of bronze. But I think that's it. I'm going to wrap this video up. You'll probably be thankful. And I'll stick some pictures on the end, should I say. And hopefully you'll get something from this.